The next problem is a free body diagram or free body analysis, or what's called static analysis, right? Um, on the laws of motion, right? So let's take a look at this. A mass m, which is equal to 8 kilograms, hang from the ceiling supported by wires with tension T1, T2, and T3. Okay, so let's look at this. So that's T1, that's T2, and that's T3. If theta 1 is equal to 45 degrees, is the angle theta with the ceiling, and theta 2 equals 30 degrees, find the tensions T1, T2, and T3. Alright, so let's label this thing. So the only piece of information this thing gives us is that the mass is equal to 8 kilograms, right? The other assumption is that basically there's gravity here, g, which is equal to 9.8 meters per second squared. And then we also know what the angles are. So theta 1 is equal to 45 degrees, theta 2 is equal to 30 degrees. Alright, okay, so let's basically draw this thing out. Alright, so what this is a balance of forces in 2 dimensions, right? So let's draw the x-axis first. So this is the x-axis, and let's draw the y-axis. Alright, so the forces all have to be equal to each other in each and every single direction, right? So that what that means is that the different tensions, right? So basically, let's write these as vectors: T1 plus T2 plus T3. All these tensions, right, at this point has to equal 0 because this point is not moving. There is no force on that, no net force on that point. Okay, so let's write these things in various components. So T1, so the x component, well, the x part of it, T1 of, well, the x component of that is T1 of x plus T2 of x plus T3 of x is equal to 0. And then the y component, this is T1 of y plus T2 of y plus T3 of y is equal to 0. Okay, so let's basically decompose these into the various components. So let's look at this analysis first along the x direction. All right. So in the x direction, all right, we can see that T3 is pointing directly along the y-axis after it's hanging, right? So in that case, what that means is T3 is equal to T3 y hat. All right, let's draw this as a vector then. Okay. Now T2, well, that's going to be equal to basically T2 of x in the x hat direction plus T2 of y in the y hat direction. Okay, let's give this a vector as well. And T1, well, it's not, we hasn't given us much space. Let's try this here. It's going to be T1 in the x direction along x hat plus T2 T1 in the x direction along the x hat, along the y hat direction. That should be y hat. Okay, very nice. Okay, so let's set these things equal to each other, right? So T1 along the x direction, well, what is that? That's going to be tension along the x direction of theta 1, which is going to be cosine of theta 1. So x is T1, which is the magnitude T1, cosine of theta 1. Now let's look at the sign very carefully. All right, which direction is this T1 pointing? T1 pointing. Well, at this point, T is pulling away from it. Okay, T2 is pulling away direction, T3 is pulling away this direction, right? At this point, it's going to be pointing in up and away from the direction, and so it's going to be pointing along the negative x-axis. So this is very important. This has to be a negative sign. Okay. Now T2 is plus T2. Okay. What's T2 of x? Well, this is T2 of x is along here, and that's going to be along a cosine of theta 2, right? And of course, it's pointing out in the positive x direction, so this is a positive value. And so this is equal to 0. Okay. All right. Now, if we plug in the numbers here, this is minus T1 cosine of theta 1 is cosine of 45 degrees plus T2 cosine of 30 degrees is equal to 0, right? So this number right here is 0.707 T1 minus plus this one is 0.866 T2 is equal to 0, right? Which means I can solve for T2 in terms of T1. So what that gives me is T2 is equal to 0. Or T1 in terms of T2. That what it gives me is basically T1 is equal to 0.866 divided by 0.707 T2, which is equal to, whoops, I ran out of space again. Okay, so be very careful about that. Which is equal to 1.22 T2. So that's T1. Okay, so let's box this information because this is going to be important later on. All right. Now, along the y-axis, along the y direction, there's going to be, again, 3 components here. Okay, so here, what we're going to get is, let's just save this piece of information for a second. Along here, we're going to get basically T1 of y plus T2 of y plus T3 of y is equal to 0. That's just this equation. I'm just writing it down again. Okay, so T1 of y, if we look at this picture right here, this is T1 of in the y direction, T1 of y. That is going to be pointing upwards in the y direction, so it's going to be T1 sine of 45. That's the sine of 45. Always pointing positive. Again, T2 is also positive again, plus T2. And again, this is going to be the sine of theta 2, which is sine of 30 degrees, right? Is plus, now, T3 is pointing in the negative direction, so this is going to basically be minus T3 is equal to 0. Okay? Now, in order to determine this equation, what we need to do is we need to figure out what T3 is, or figure out one of these two, right? Turns out the easiest thing to figure out what T3 is, T3 would be by looking at the last piece of information, which is the information right here. Okay? So we look at this point and we draw a free body diagram there. Okay? There's going to be a mass times gravity there, and then there's going to be a T3 there that balances that, right? So what that means is that mass times gravity, which is coming in negative because it's pointing in the negative y direction, plus T3 is equal to 0, which means that T3 is equal to the mass times gravity. Okay, so that's really nice. Okay, so T3 is equal to mass times gravity, which is equal to 8 times 9.8 meters per second squared, which is equal to 78.4 newtons. All right. Okay. So with this, we can actually solve it. Okay. So let's take this number and plug it in this equation right here. So again, we have T1 sine of 45. What sine 45? Well, that's 0.707 plus T2 sine of 30 is 0.5 minus 78.4 newtons is equal to 0. Okay, so we still don't have enough information unless we remember that T1 and T2 are related by a factor of 1.22. So T1 is equal to 1.22 T2. So let's plug that into here. Right. So this is going to be equal to 1.22 of basically T2 times 0.707 plus 0.5 T2, all right, minus 78.4 is equal to 0. Okay. If you write out these two numbers, it turns out this is going to be something like 0.866 plus 0.5 T2 to 0.866 is equal to, bring this to the other side, 78.4. And so you end up getting that T2 is equal to 78.4 divided by 1.366. This is 0.866 plus 0.5 is 1.3866, right? All right, so I'll leave it to you to basically solve for this value here. But once you know this, you can determine T1, and you already know what T3 is. And that solves this particular problem.